Hey everyone, Mr. Regan here, and up to this point, you've been playing quite a few rounds of golf, trying to use force, mass, velocity, and collisions to knock some objects in our sim into a target using as few a number of hits as possible. Hopefully, we've had a little fun with this as we tried to apply our science knowledge to this game. But today, we're going to take a step back and look at applying our game of golf to some real world scientific principles. Up to this point, you've spent the vast majority of our unit looking at how force, mass, velocity, and collisions work. And as you went through our units, coming up with some key concepts, some key ideas, principles, or rules for how things move and what the science behind force, mass, velocity, and collisions is like. And though those key concepts are true for how different things move, those key concepts are actually broken down from larger real world scientific principles created from a scientist named Newton. Now, long ago, Newton created a set of scientific laws and principles that help explain how things move around the world and space and so on. These laws have held true for quite some time now. And though our key concepts come from them, they are just bits and pieces of them. So today we're going to be looking at not only understanding Newton's three laws, but looking to apply them to our game of golf. So this might seem familiar compared to things that we've done in the past, and it is indeed very familiar. Every time that you guys take a test, we would review the key concepts where your job was to come up with the key concepts and apply it to some real world example. So in our chapter 3 summative, your job was to apply our key concept to a game of bowling that was happening. So you first came up with your key concept. A force is required to change the velocity of an object. And then your job was to find what evidence from the diagram, in this case, the bowling diagram, shows this key concept. And your job was to connect the key concepts directly to what was happening in the diagram. So for example, a force is required to change the velocity of an object. The bowling pins had no velocity as they sat at the end of the lane. So we're talking about the velocity of an object before something happened. When the bowling ball hit them, a force was applied to the pins that changed their velocity. So now we're talking about a force that's required to change the velocity. The pins went from having no velocity to starting to move. So notice I'm talking about examples of velocity changing because of a force. The pins had no velocity, a force was applied, they started to move. And when we did this, we acted as every scientist has ever done in the history of science, looking to apply scientific principles and ideas to the real world around us. So whether it's a game of bowling, whether it is how cars move, game of billiards, a space pod and space station problem that a ground team is trying to fix, our key concepts help us explain what's going on, whether it's to solve problems or just understand the natural world. So today we're going to do the same idea, but we're going to do it using the actual laws that these key concepts come from. And that's Newton's three laws. So Newton has three laws for how things move in the universe. The first law, in the yellow one, says an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion will continue at a constant speed and direction unless acted on by an unbalanced force. So similar to our key concept that says a force is required to change the velocity of an object, this breaks it into two ideas. An object at rest will stay at rest or not moving, and an object moving will stay moving until a force is acted on it. So a force causes it to stop moving, to speed up, or to do many other things. So your job will be to think of an example of how Newton's first law shows up in our game of golf. So all the sim games that we played, all the different holes 1 through 8, how does it show up? What's an example of it? Where can you find evidence of this law being true? Next, Newton's second law. The acceleration of an object depends on the mass of the object and the amount of force applied. In other words, how fast an object goes depends on how much it weighs and how hard we hit or push it. So your job will be to find an example of that as well in our golf game. And last but not least, for every action, there is a reaction force equal in strength and opposite in direction. So thinking about our collisions and all the key concepts we came up with our collisions, This is where this law helped us figure out those collision keep concepts. So your job again will be to find an example for every action force. In other words, every time a force is applied, there is a reaction force or force equal in strength and in the opposite direction. So again, thinking about all of the games of golf you played, everything you saw on the analyze page, where does this law show up? So when you get to this next task, you can click on the diagrams to see those three laws that we just showed you. And your job will be to find an example of Newton's first law, second law, and third law for the game of golf, looking to apply real scientific principles to a real world example, in this case, golf. Now remember, just because we don't use Newton's laws in our classroom doesn't mean that the key concepts that we came up with aren't examples or bits and pieces from Newton's laws. So your job is now to act as a real scientist using real principles and connecting them to the real world. So hopefully, number one, we understand Newton's three laws and how to apply them to our golf game. If both of those things are true, put your X in green and good luck. If one or more of those things aren't true and you put your X in yellow or red, reach out. And as always, if you need help, come find me. Good luck, and we'll see what you're able to do.